Thank you so much for having us today. Philip's going to go ahead and get plugged in, and then we'll get rolling.
Yeah.
Live coding ready?
Almost ready.
Emulator locked and loaded? All right.
Hey, on there. OK.
Cool. All right. Well, thanks so much for joining us. My name is Brian Egan. I am the co-author of Rx Dart, which is the reactive extensions for the Dart language. And I'm joined by today.
Hi, my name is Filip. I'm a developer advocate for Flutter at Google.
All right. And so today we're going to be talking about practical applications of reactive extensions with Flutter. But we hope this talk will be practical and applicable to other areas of expertise as well, such as JavaScript or Android development or Swift development. We're hoping to talk more generally, but we'll be using Rx and Flutter to implement these concepts. So in our case, we're going to be talking about building reactive apps. And just to really set the stage before we really dive into the practical part, we can sort of think about two approaches to developing apps, right? And so in most apps, right, you have some sort of data source or some sort of component that talks to a data source. And something will change with this data source, right? And then we need to update our UIs, like the classic problem. And so there are a couple different approaches. The first, of course, is a proactive approach. So in this case, the component that talks to your data source, it might drive the UI and tell it exactly what to do. So if we were building a search screen and you enter the screen, your proactive component might say, OK, UI, go ahead and show the no term to let the user know they can type something in. And then as the user starts typing something in, we're going to want to fetch some search results. And so our proactive component will say, OK, let's hide that no term, and let's show the loading spinner instead. Finally, when the results come back, that proactive component will say, OK, now it's time to hide that loading spinner and show the results that we've received. And this is actually a really popular approach. If you come from Android development and you've worked with something like the MVP pattern, it's really common to have this presenter component telling a view component what it needs to do. But one thing that I experienced and that other, I think, folks might experience is that you can get some interesting bugs with this, right? So say those search results come back, and for some reason, your presenter or the component that's driving the view it doesn't tell it to hide the loading spinner. It just tells it to show the results. And this is an actual bug that I've seen on apps and that I've done myself, right? Bugs, they crop up. And so it's really interesting. So sometimes you'll actually see some apps where they're almost like showing two screens on top of each other. And that's a really interesting bug. And it's a difficult bug to solve because you kind of need to go through your proactive component and figure out, OK, where along the way did I mess up? Now, if we compare that to a reactive approach, right, in this case, what we will do is, rather than having a proactive component telling the view what to do, we'll allow the view to respond to events. And in this case, we'll be listening to a stream of events. And now we can almost think about our view as a function, right? We get some input, and we expect it to have some UI output. For folks at this conference, I'm sure this is stuff you're doing all the time since we're at ReactiveConf. And so in this case, what we're going to do is we're going to be listening to a stream of events. And this stream of events will deliver different data over time. So it might deliver the no term. And your UI can simply take that data and render the correct UI. Then when it's told to show the loading spinner or that something is loading, your UI knows what to do. And finally, when the results come back, it will know, hey, I need to show those results, right? You have these inputs, and you present a UI output. And this is really nice for larger apps, where you probably are going to be having screens or widgets or components that are listening to multiple data sources. And this is nice because you have essentially a single code path, right? You know that you have some input and an output. And so if you happen to have this mistake where you might be showing two things run right on top of the other, you just need to go and look at your sort of functional transformation and say, hey, given this certain input, why am I delivering this screen? So that's the theoretical part, and we just wanted to use that to set the stage. But I think it's time to get practical, and let's go ahead and build a search screen. So what we'll do is we'll actually live code a search screen, and we'll start with a little bit more of a proactive approach, and we'll refactor it into more of a reactive approach using the reactive extensions. In this case, we'll also be using Flutter.
Right. So Flutter is a mobile app SDK, right? It's something for building or toolkit for building apps for iOS and Android. And one of the characteristics of this is that it compiles to machine code, right? It compiles to native ARM code that then paints right directly to OpenGL or Vulkan. So we do that because we want to enable apps like Reflectly here. Reflectly is an app that was published not so long ago. And as you can see, it's very dynamic, it's very animated, it's very smooth as well. The compilation to native code enables that. So the reason why we want to enable apps like this is that if you look at app stores today, these are the top apps, right? They're not kind of cookie cutter apps. They're very custom and very animated. Flutter is a reactive or like a declarative framework. So it makes sense to use something like Rx or reactive programming in general. It actually is even impossible to do anything else. But it's not like Rx is not the only approach that you can take. The reason why I'm talking here about Rx is that big Flutter apps built at Google are using Rx. And so that's what I have some experience with. So let's actually live code or show some code here, right? So on the right here, we have an app, or we have a screen in an app that just searches things. So I can, I search, these are vegetables and fruits, and I can search for a term, and it will give me immediately some kind of results. It will filter the results, right? And obviously, it's a screen. So in Flutter, how you would do that most of the time is using a StreamBuilder. Everything in Flutter is a widget, and StreamBuilder is a widget. StreamBuilder is conceptually is very easy to understand. It takes a stream of data, and then anytime there's a new event on that stream, it will use this function to rebuild itself or rebuilds its children, right? So, and then in here, we just generate the rows and all that. The results or the stream of results is some kind of API, right? Like we have some kind of object somewhere that is taking care of the search. And here we just listen to it. And on another place, here actually, we are creating the search box. And we're winding it up to a controller, and then that controller, anytime there's a change in the input box, we will just put the term into that API, and then here we listen to the outputs, right? The cool thing about this is that the view code doesn't really need to worry about how that search service is implemented. It's just like it gives it the terms that you're searching, and then it also is reactively listening to updates to the search results. So we'll spend most of our time now in the search service, and basically just with these few lines, right? So right now we have this kind of like half reactive approach where we're listening to the stream of search terms. And anytime there's a new term, we are using our search API to asynchronously ask for the results and then add them to the stream of results, right? So let's see, it kind of works as I showed before, right? And so you can search for different things, and that's great. But this is an ideal case. We are actually, so I instrumented the search API to always return the result after, I think, 200 milliseconds, right? Which, in a test, that's great, but then in real life, that's not going to be always the case. So I also instrumented it so that one particular search will take much longer, and that's the search for the letter P. So if I search for letter P, just letter P, it will take something like a second to get the results back, which is more realistic. You have things that will take more time, things will go out of sync, and so on and so forth. right? So if you only search for letter P, that's just, it's just annoying, but that's not a big deal. But most people don't search just for letter P. Most people search for something like pine, because they want to search for pineapple. And then, did you see what happened? I searched for pine, and it was there. Pineapple was there for a minute, and then it was rewritten by the search for the letter P, because it went, it came later. So what the hell, Brian? You said you said Rx is great.
Yeah, you just more problems, right? So in this case, right, we're dealing with async code, as Filip mentioned, and we're dealing with a problem where we can't guarantee that these results will come back in order. So in this case, the happy path, right, is you search for the letter P, and the results come back within, constant time, 200 milliseconds, then PI, then PIN, and then pine finally. And in this case, your UI will be just fine. Your users won't notice any bugs. You might think like, hey, I've developed my feature and it's working, so I'm going to ship it. But then maybe your users are out in the wild and they get bad 3G or something for a few minutes. And they search for the letter P, as we've sort of instrumented here. And all of a sudden, that's going to take maybe 2 to 5 seconds or even longer. But then they keep searching, and for some reason, those next results come back just perfectly on time. So what's happening is that we're actually displaying the results for pine, but then the search results for the letter P come back, and it just wipes out what we had previously. So that's what the effect you were seeing on screen. And that's why at first you saw results for the search term pine, and all of a sudden it just got wiped out. And so this is an interesting problem, and I think we've got a solution for it. So
yeah. So one thing that we can do is actually, again, look at Rx and what it gives us, and think about the search screen as a function, right? So search screen is a function that takes the search terms and returns the search results. That's all it does, right? It's a pure function, and it just happens to be, shown on screen, and it happens to be asynchronous. So that's exactly what Rx is for. So instead of just creating a new result subject and then adding things to it, we can just transform the search terms through things and then return the result. So we're not going to use this. We're actually starting with search terms, and then whenever in functional reactive programming, whenever you're trying to transform one iterable, in this case, it's an iterable that is asynchronous, so stream. But if you are mapping from one stream to another stream, what do you use? Map, right? We could use map. Well, we can't use map because what we are using, the API, is asynchronous. So what we need to use is async map. So let me do just that.
all right. And so in this case, async map will take in a function, and it needs to return a future. And in this case, if you come from the JavaScript world, you can really think of a future just like a JavaScript promise. They've got a very similar API. So in this case, we're marking the function as async. We're going to await the result, and then we're going to return that result. So let's see if that actually fixed up the problem.
So I search for pine, and it fixes the problem. As you could see, that there's no longer a race condition, but there's another problem. And that's that we are actually waiting for the P to finish before going ahead, right? So from the experience of the user, that's actually not that, it's better because you get the result in the end, but it's actually a pretty bad experience. You're waiting for that long time. So there's something wrong here. So maybe async map is not the operator that we want to use, Brian.
I guess not, yeah, okay. So we're gonna try out another operator. This one's called switch map, and this operator is a bit different in that every time a new search term comes in, it's just going to go ahead and discard any of the previous search terms that were in flight. So if it's making some calls or doing things like that, it's just going to say, hey, drop the last call that you were making, and let's only use the latest call. So in this case, what we've done is we've transformed the function, and switch map actually needs to return a stream of events rather than a future. So what we've done is we've actually gone from an async function to an async star or an async generator function. And this is really nice because it provides a way for us to actually emit values via the yield keyword. And so this will actually return a stream. And every time we say, OK, yield the results from the back end, then that'll get emitted as part of a stream, and everything just works.
So I search for fine, and there we go. So we don't have the weight, and we don't have the race condition, and so everything is great. Except, as you can see here, we're printing every time that we're actually making a request to the search API. So like if I search for Apple, you can see that we're actually creating every request along the way. Apple, and then Apple, finally, right? Switch map is great because it cancels all these things, but that still means we are starting those requests, which is pretty bad for the battery. It could be bad for your data. It could be bad for your backend because like you're basically trying to send back all these things that nobody really needs, nobody really wants. So what can we use for that?
Yeah, so what if we just waited and allowed the user to pause for a couple seconds, or maybe just half a second, before we actually ran the search? And to do that, we can actually use another operator provided by RxStart, which is the debounce operator. And what this will do is this will listen to the stream of terms as they come in, and then once the user pauses, in this case for 500 milliseconds, then it'll forward that last thing on to our switch map function. So now if we take a look at it.
So if I search for Apple, now I really only search, as you can see here, I really only search for Apple and not the intermediates, right? If I'm too slow and do something like this, it does search for app, but not things that are intermediate. Right?
Yep.
OK, cool. So we have this. We fixed our problem. We are pretty happy with ourselves. But then the PM comes and he says, she says, you know what? We actually have a new requirement. There is a new stream of data. It's like a live data stream that says which veggies and which fruits are out of stock at this moment. And so this can happen at any time. And we don't want to show veggies and fruits to people which are, the ones that are out of stock, we don't want to show in search results, right? So this is great, but this kind of breaks our nice approach almost, right? Because we are listening to this stream of events, and now we have another stream of events, and we somehow need to, I would almost say, combine it.
Yeah.
Yeah.
Well, luckily, we have the combine latest operator with RxStart. And so the combine latest operator is really nice because what you can do is you can essentially listen to 2 or 3 or even more streams. And whenever one of those streams changes, you can run a function to combine the results from both of those streams and output that combination. So in this case, what we'll use is we'll use the combine latest 2 factory method. And this will take in the stream of results, which we started with and we've already looked at. And then it'll take in this other stream that informs us with live updates of which veggies are in stock or out of stock. So what we'll do is we'll listen to both of those streams, and we'll create a combiner function. And what this function will do is it will take this list of results that we've got from our search service, and we'll combine it, and we'll filter it using the out-of-stock veggies. And so in this case, if a vegetable is out of stock, we'll just go ahead and filter it out of the list. And this is using the where keyword, which is similar to filter if you come from JavaScript world. All right. So we've got our combiner.
I think I have it. Oh, maybe I should actually, yeah, I should actually use the result, right? Does it help? OK.
Cool. All right.
Hot restart.
All right. Demo gods are with us.
Yes. So anyway, so now we're searching for everything. And I've instrumented the app so that, what was it? Cranberries? Yeah. cranberries go out of stock every second and then get back to stock every second. Weird, but that's what happens. And so, here it's not that great, but like if we actually search for berries, then we see that these two things are actually combined. So we do get back the result of the search, and we are combining it with the live data that is come from our API, and we're combining the two. Great. So I think we are done here.
All right. So let's go ahead and do a quick recap and talk about these different operators that we just saw. So the first thing we saw is that with async code, we can deal with ordering issues. And so the Rx reactive extensions, whether it's for RxJS, RxJava, et cetera, or RxStart, they allow us to solve this out-of-order problem with the switch map operator. And so, as I said, this will basically discard all of the previous results that were being loaded and only worry about delivering the latest results to the user. But the cool thing is, and this is really kind of the more general point of this functional input to functional output, or streams of input to streams of output, we can actually use other types of map as well. So in the case of infinite pagination, you might have a stream, and as the user is scrolling down your page, whether it's on the web or a Flutter app, and maybe they're getting about 500 or 1,000 pixels away from the bottom, and you want to start loading some data. So you might emit a stream of, hey, load the next page, as a user is getting closer to the bottom. In this case, however, we might emit this event a lot of times, especially if it's listening to like a scroll controller or the window on scroll event. And so what we want is we want something that will fetch the next page when it's first told, and then it'll kind of just ignore the rest of the input. And for this, we can use exhaust map. And so it's perfect for this situation. So as the user scrolls towards the bottom, you've got this stream emitting events to load the next page. You have a function that is using the exhaust map operator. It'll load the next page. And then when it finally has results, it'll deliver those results. And at that point, it'll update your UI. And at that point, you shouldn't be that close to the bottom anymore. So you can actually just kind of keep going. So this is just really to make a point that there are a variety of maps provided by reactive extensions: flat map, switch map, exhaust map, a few others. And these can be really useful for different situations when you need to control what data should be delivered to your view or your UI. The other thing we saw is the ability to combine streams. And in most cases, in our case, we had this cranberries example, and it just sort of went in and out of stock. And you might think, OK, that's like kind of a fake example. But this is something that I've done in production. So when I worked at SoundCloud, we've got, for example, a playlist. And as you're playing that playlist, you might see that the player will change tracks. And when it does, you want to update the playlist to show which track is currently playing. So you can sort of see this now playing moving down the screen as the tracks are changed. And this is a classic combination of using combine latest. Say, hey, give me the playlist via a stream, and give me the current now playing track, and I'll display every time that now playing track emits a new item, I'll just emit a new value, and my UI will reflect that value. So this is the combine latest operator, and it's a super handy operator for a lot of different situations. Another interesting situation, and this is another example we've got. I was just another one from SoundCloud because I worked on this screen, and so it's really, I actually really like this one. When I found out about concat, I was like, yes, this solves my problem perfectly. So in this case, you might have a few likes stored in your database, and then we also want, as you're searching, to call a web API and get search suggestions. And so what we can do is we can use the concat operator to combine streams. And so what we'll do is we'll first load the results for local tracks, and then we'll next make a call to our web service. And so this delivers results really fast because it'll start with the local results, which usually come back within just less than 100 milliseconds. And then it can worry about fetching the other stuff. And so you can see here, it starts by displaying the local tracks, and then in a second port, it shows the search suggestions. So yeah, there's different ways to combine streams. You can merge streams, you can zip streams, you can concatenate or combine latest. In general, this is one of the cool things about Rx is that it allows you to do these types of combinations. And I think kind of create like almost computed values from 2 different live streams of data. And finally, of course, we saw our overfetching problem where we kept searching for every single letter. And in order to solve this problem, we used something like debounce, which just allowed us to say, hey, let the user chill out for 500 milliseconds, and then we'll call our backend. And that was really good, as Filip mentioned, because this will save your phone's battery life or your user's phone's battery life. Maybe if they're on a restricted data plan, it won't actually end up making these API calls to try to fetch this data and consume a data plan that's limited. And of course, for your own servers, you don't want to hit them with too much unnecessary traffic. It not only costs you money, but it could also, of course, lead to issues. If you have millions and millions of users all searching for app, just AP, and it's like a useless search term. So if you'd like to see more, we've got a series of examples here. And so you can go to the RxStart repo, where we've got a similar search example. Or we also have something like Flutter architecture samples, which is similar to to-do MVC. And we've got a stream-based version of that architecture. So you can sort of see how to use the reactive extensions on maybe a slightly more complex, although not a super complex app. And finally, we showed the example with infinite pagination and how to use exhaust map to achieve that. And if you'd like to look at that, you can check out this MVI sealed unions repository.
Yeah, so what we wanted to show you today is that Rx is not some kind of mythical or mystical thing that only lives in with marbles and with people who like understand functional programming from universities, but it's actually really practical, and there's no reason to fear that, and it is used in real-world apps today. So thank you.
Thank you very much.